Hello everyone, in today's math challenge, we will look at the 5 random integers question. Among any 5 integers, it doesn't matter whether they are positive or negative, whether all or some of them are the same or all of them are different. We are just talking about any 5 integers. So can you prove you must be able to pick up 3 of them with the sum being multiple of 3? And here, it is not really useful if you randomly select 5 integers and pick up 3 of them to make the sum being the multiple 3, because this will not apply to any other 5 integers. And here we must use some mathematical theory to prove it universally. You can pause this video and spend as much time as you need, and then we come back for the answer. Okay, let's have a look at the answer together. If you have manipulated numbers a lot, you should have such experience. For example, if an integer is divided by 3, the remainder could only be either 0, 1, or 2. It's not possible to be anything else. For example, if the remainder is 3, actually it should be 0. So that means any integer can be expressed as the format of 3x plus y. And here the x can take any integer value, and the y can only take 0, 1, or 2. So that means for these 5 random integers, they can be expressed in the format of 3a plus 0, 3b plus 1, or 3c plus 2. And here, a, b, and c can be any integer values. And when we add 3 integers value together, you will see it is not very important for the left part, because they are already the multiple of 3's. No matter how many you add them together, the result must be also the multiple of 3. And here we just focus on these remainders. They could take the possible values of 0, 1, and 2. It may be easier if we start with 4 random integers, with the remainders being 0, 0, 1, and 1. And here you will see it is just not possible to pick up any 3 of them to make up the multiple of 3. However, if the fifth number is allowed here, and its remainder could be 0, 1, or 2, and we will see if its remainder is 0, so we can pick up these 3 numbers with remainders of 3, 0, and the sum of them is 0, is a multiple of 3, so the sum of these 3 numbers must be the multiple of 3. And if the fifth number has a remainder of 1, we can pick up these 3 numbers with remainders being 3 ones, and if we add them together, it is 3, and it's multiple of 3. If the fifth number has got a remainder of 2, we can pick up these 3 numbers to add them, with the remainders being 0, 1, and 2. So the sum is 3, is the multiple of 3. So that means the sum of these 3 numbers must be the multiple of 3. And in the other 2 extreme cases from the first 4 numbers, their remainders could be 0, 0, 2, 2. And again, you cannot find any 3 remainders to make up the multiple of 3. However, with addition of either 0, 1, or 2, you will be able to. And the same case will apply for these 4 possible remainders. So the conclusion here is you must be able to find 3 of any 5 random integers to make the sum of the remainders to be the multiple of 3. So the sum of these 3 integers must be the multiple of 3. So actually this question will help us to be more familiar with the characteristics of the numbers, which could be extremely useful to our mathematical calculations. So here is one bonus question: how to quickly judge whether a number is a multiple of 3 or not. For example, we could have a quite big number like this 95,001. Can you tell whether it is a multiple of 3? Actually, you don't need to divide this number by 3 and see whether the remainder is 0 or not. There is a better trick. Actually, you can just add all the digits in this number and see whether the sum of these digits is the multiple 3 or not. Okay, so if it is, that means the whole number will also be the multiple 3. For example, here, 9 plus 1 is equal to 10, and plus 5 is equal to 15. And 15 is multiple 3, so that means this whole number, 95,001, must also be the multiple 3. So this is a very important mathematical trick you can apply in the reality. Okay, thank you very much.